Hi students, welcome back to my channel. Today let's learn about S block elements. So this is the periodic table. If you observe the periodic table, we all know that elements are arranged according to increase in atomic number. Now as and when the elements are arranged according to the increase in the atomic number, we also see a pattern. So this pattern is based on the filling of electrons in orbitals. That's the classification based on the type of atomic orbitals that are being filled. Mainly, let's consider the valence electron. So, based on this valence electron, you can observe that there are certain divisions in periodic table, or there are blocks. There are four types of blocks which have been made in periodic table based on the valence electron. So, the first is S, and the second is P, the third is D, and the fourth is F block. So now SPDF, we are already aware they are the names of orbitals. So when the valence electrons are present in the S orbital, they are named as S block elements. Similarly, when elements are placed in the P orbital, they are named as P block. And when elements are in placed in the D orbital, they are named as D block. So now let's understand this with respect to the periodic table. Now, if you observe 1 and 2, group 1 and 2, they are the S block elements, and 13 to 18 is P block elements, and in between 3 to 12 they are the D block elements, and lanthanide and actinide, that is from 58 to 103, they belong to the F block elements. So now again here this classification based on how the valence electrons are located in the orbitals. Okay, so let's learn about S block elements today. So as I already told you, group 1 and group 2, they are called as the S block elements, mainly because their valence electrons contain the S orbital, or the valence electrons are present in S orbital. Now I will explain this in detail as we go ahead. So now first, let's go through the content. Okay, now here the group 1 elements, okay, they are called as alkali metals. So alkali means we know a strong base is called as alkali, right? So now when you take lithium is one of the group 1 elements. Similarly, sodium is one of the group 1 elements. So now when it is mixed with water, what are we getting? We are getting LiOH and we are getting NaOH respectively. Now these are examples of alkalis because they are very very strong base, primarily used in um, detergents and soaps, mainly as cleansing agents, right? And they also have a property to convert or change the red litmus paper to blue. And we all, some of us also are aware about base, that they are highly corrosive also. If we cannot touch the NaOH pellets directly with our hand, it will corrode our hands. Okay, so now these were given the name as alkali because they acted as very strong base. Now the second group, they're called as alkaline earth metals. Now I've taken some of the examples. I've taken beryllium and magnesium. If you observe beryllium and magnesium, when they are treated with oxygen and water, we are getting their oxides and hydroxides. Now these oxides and hydroxides, students, it is said that they are obtained from the earth's crust. It could be magnesium hydroxide, or it could be beryllium hydroxide or calcium hydroxide. So they are obtained from the earth's crust directly with a huge percentage. So that's why they were named as alkaline earth metals. They were named as alkaline earth metals. Okay, now this is the name given to group 1 and group 2 elements, alkali metals and alkaline earth metals. Now let us understand. So now coming back to the electronic configuration of group 1 and group 2. This is continuation of this previous slide which I was trying to explain about why group 1 and group 2 are called as S block elements. Now here let's understand a very simple with simple example. Let me take lithium first. Now, lithium has atomic number 3. And when we arrange the electrons in the shell, then we can arrange them in K and L shell with 2 electrons in K shell and 1 electron in L shell. So that is, if I have to write down the electronic configuration, it will be 1s2 and 2s1. Now observe carefully, students. Valence electron. So valence electron, which is a valence electron? 2s. 2s is the orbital, and 2s in 2s orbital, the valence electron is located. So now if you observe carefully, the orbital is 2s. So where is the valence electron present? It's present in s orbital, and it is present in L shell. So this 1, 2, 3, as we all know, they refer to the n. N value is principal quantum number, and SPDF, they are representing the azimuthal quantum number, or they are representing the orbitals. So now that's why group 1, they get the general formula as NS1. NS1 becomes their outermost electronic configuration. Now here, as I already told you, N is referring to the principal quantum number, the shell in which it is present, and S is the orbital. Okay, so this is NS1. Now, let's take one more example. Let's take sodium. So in sodium, what's the atomic number of sodium? It's 11. And if I have to write its electronic configuration, it will be 1s2, 2s2, 2p6, and 3s1. Now observe the valence or the valence electron, or the valence orbital. Valence orbital is going to be 3s. So in 3s orbital, I can observe one electron. So it will look like something like this. So let's say this is the nucleus, and this is K shell and L, and this is the M shell. So now here in M shell there is one electron. So now this electron is the valence electron. Okay, now this is the valence electron. Now if you observe the valence electron, what is the configuration here? 3 becomes, I can call the 3 as the third shell, that is M shell, and it is 3 is nothing but the principal quantum number, so I gave it the name as N, and S is the orbital, and 1, so NS1. So here again we are observing the general formula of group 1 elements as NS1. So if I go back to the periodic table, here all of these students, okay, lithium, the first one, lithium, magnesium, potassium, rubidium, cesium. So all these group 1 elements, what are they having? They're having a general formula NS1. Okay, that is, all of them have one the valence electron in the s orbital only. That's why group 1 elements are called as s block element. Okay, now I hope you're getting a clarity why the blocks were given. So blocks were given, or it was categorized mainly based on the electronic configuration, the valence electrons. Now similarly, when I observe second block, now let's take an example of second block. I will take beryllium. Beryllium, we know, atomic number is 4. So if I distribute electrons, electronic configuration 1s2, 2s2. Now here if we observe carefully, 2s is the valence shell, valence orbital of beryllium, and number of electrons in the valence orbital is going to be 2 here. So that's why the general formula for group 2 elements was given as NS2. So here N is principal quantum number, in this case it's 2, and S is the orbital, and superscript 2 refers to the number of electrons. So beryllium, if we talk about the arrangement of beryllium, so it is having 2 electrons. This is one electron, and this is the second electron. So there are 2 electrons in its valence shell. Okay, and they are and it's having a general formula. Group 2 elements have general formula as NS2. Now this 2 again I am telling you, it refers to valence electrons, means the outermost electrons present in a shell or an orbit is called as valence electron. Now similarly, let's take one more example. Let's take magnesium. Magnesium also belongs to group 2. Its electronic configuration is going to be 1s2, 2s2, 2p6 and 3s2. Now here again observe valence electrons. Valence orbital is 3s and electrons present or valence electrons are 2 in number. So it is going to be ns2 as the general formula. So now here n refers to principal quantum number. Here it's 3 and s is the orbital and 2 are the 2 is the electrons. Okay, so now this becomes a general formula for group 2. Group 1 has ns1, group 2 has ns2, means all the elements in group 2, that is okay, that is going to be beryllium, magnesium, calcium, strontium, barium, radium. So all of these elements, what is their general formula? ns2, means their valence electrons are 2 which are present in the outermost orbit. That's the meaning. Okay, now let's go ahead with some of the properties of the group 2 elements, group 1 and group 2. Their ionization energy is very less. What's meant by ionization enthalpy? The amount of energy required to remove an electron from an isolated atom or molecule. Now, why is it so? Let's understand. Now, let's take this the nucleus and this is the orbit. Okay, and then it is the K shell, and then we have the next orbit, that is M shell. Okay, so now let's take the example of lithium. So, lithium has 3 electrons. Atomic number is 3 and it has 3 electrons. Now, if we observe why is the trend in the periodic table in such a way, is because there are many reasons for that. Okay, now first of all, let's understand what's meant by ionization energy. The energy required to knock out or remove the valence or an isolated electron, sorry, to remove an electron from an isolated atom. So here primarily we're talking about valence electron. Okay, so the energy required to remove the valence electron from its outermost orbit becomes the ionization energy. Now this energy goes on increasing as we go from left to right, that is across the period. Okay, if I take lithium and if I compare it with neon, neon will be having the highest ionization energy and lithium will be having the least ionization energy. Now why is it like this is we have to understand that nucleus, students, is the, just like how we have a cell, right? Cell is the main uh, part which is helpful for the proper functioning of the body, right? So when cells are healthy and happy, only then the person can be healthy and happy, whether it's a mind or whether it's the body. Similarly, when we talk about the nucleus, nucleus has its own energy, right? And this energy is minimum supplied for group 1 and group 2 because there are less number of electrons, right? Now as less number of electrons in the orbit, now as the electrons go on increasing in the orbit, the energy goes on increasing. So now if I take example of lithium and neon, lithium has only 3 electrons but neon has 10. So now because there are 10 electrons, nucleus will have to give in or provide more energy. Now because of that, what happens? The ionization enthalpy of neon will be higher, but whereas ionization enthalpy of lithium will be very less because there are only 3 electrons to manage. It's just like a classroom of 10 versus a classroom of 50. So the teacher doesn't have to, shout or put in more energy to teach a classroom of 10, whereas she'll have to put in more energy and thoughts and creativity for a classroom of 50 because there are more kids and each one of them are totally different, right? So just like that, when the nucleus has less electrons around its orbit, then the energy required for the nucleus to hold the electrons will be less. So when it is less, these electrons can easily be isolated. That's the meaning. Okay, rather than when the electrons are more, wherein the nucleus will have to hold them tightly. Okay, so that's the reason, one of the reason why atomic, and that's what I've written here, atomic size. Okay, atomic size plays a very major role in understanding the ionization energy. Now the second is called as a shielding effect. Now let's understand the shielding effect. So then this is the nucleus, this is the K shell, and this is the L shell. Now when electrons in K shell, okay, they will be shielding the electrons from the outer orbit. Okay, just like how the soldiers guard the border, just like that. Similarly, the K shell electrons also will be guarding, or they'll be shielding. So now in this way, what happens? The electrons in L shell and the nucleus will be having minimum attraction, because here the K shell electrons are placed, right? So this way also what happens? The energy or these electrons in L shell can easily be removed quickly, okay, with less energy. So this shielding effect also plays another major role in ionization energy, ionization enthalpy. So when shielding effect is stronger, ionization energy is very less, because the electrons will be very loosely placed in their orbit, and the attraction between the nucleus and the orbit will be very less. Okay, that's the reason, that's the outer orbit. So that's the reason why electrons will be easily knocked away. Okay, so that's the reason here. So that's what I've mentioned in this slides. Alkali metals have largest atomic size within their respective periods, meaning valence electrons are farther from the nucleus, weakening the attraction. And coming to shielding effect, the inner electrons shield the outer valence electrons from the full positive charge of the nucleus, reducing the attraction. So that's what I've been telling you here. Okay, so these are the, if I call them as the inner electrons, K shell as the inner electrons, the K shell will be shielding the outer valence electrons. So that's the reason why L electrons, or electrons in the L shell, can easily be removed. Okay, so that's called as shielding effect. Now, apart from this, let's also understand some of the properties of S and S block elements. Metallic character. So now when we talk about metallic character, as we go down the group, students, the metallic character, it increases. Okay, that's lithium has less metallic character, whereas cesium will be having higher metallic character. Okay, now this is the reason why most of the most of the metals are not present in their native form. See, when native form means pure form, only some of the elements like silver, gold, and platinum, only these three are the metals which are present in their native form. Pure form means which they are not formed in any combined state. Okay, but whereas most of the other metals, they are, because they are highly reactive, what happens is their metallic character also goes on increasing as we go down the group, and that's the reason why they are present as present in combined state. So that we will learn here in the next slide. Coming to reactivity, so as I already told you, reactivity increases as we go down the group. If I compare lithium and cesium, lithium will be having less reactivity and cesium will be having higher reactivity. So that's the reason why most of the metals are present in combined form. That's what we call as minerals. So in Earth's crust, there are many types of minerals, right? So some of the examples are given here for sodium and magnesium and potassium. Sodium is always combined with chlorine to form NaCl, common salt, what we call sodium chloride. Similarly, magnesium is present in the form of magnesite, that is a combination of carbonate, magnesium and carbonate. And then potassium is present in the combined state as carnallite with magnesium chlorine and 6 water molecules. So now this is becomes a solid. These are all solids, like how they are present in the, like a stone, like in Earth's crust. And then they are separated using the metallurgy process. Okay, so this is all about S block elements. I would kindly request all of you to please subscribe to my channel. Thank you.